Hello, dear student. How are you doing today? This is your teacher, Ms. Regine from Knowledge School. Our today's lesson is about section 2.2, Young's modulus sample problem 2b, which is on page 41 and 42. So you have to know what is Young's modulus definition, which is the ratio of stress to strain of a given material, and the unit is Newton per meter square. So this formula of Young's modulus are important, which E is Young's modulus, and sigma is stress and epsilon naught is strain. But sigma equal F over A and epsilon naught equal delta L over L naught. So this is our formula. Okay, sample problem 2b on page 42. A steel wire of diameter 0.40 millimeter and initial length, which is L naught, is suspended vertically from a fixed point and a weight of 80 Newton, which this is the force, okay, is connected to its lower end. The resulting elongation of the wire is 6.4, which L minus L naught, which is delta L, okay? Delta L equals 9.4 millimeter. Calculate Young's modulus of steel, which you have to find E, okay? It's unknown. So always remember that you have to know how to, find the units, okay? Or you have to use metric length conversion, or even if it was gram or kilogram or whatever unit is, you have to write it that if it is big unit, you have to write big units, or if they are smaller unit, you have to write on smaller unit. So here, as we will find the Young's modulus, which is a Newton over meter. So we have to convert all our millimeters to meters. Okay. So here we have diameter. We don't use diameter. What we will do, we will change it to radius. Okay. Next slides, I will talk about the diameter. Okay, here it is diameter on millimeter, so we have to change it to be in meter. As you have millimeter here, when you change it to meter, you have to divide it by 100. So you have 10 here and 100 here, so you have to divide it by 1,000. Okay, millimeter to meter, you will divide it by 1,000. Okay, when you divide it by 1,000, okay, divided by 1,000, it will equals to 10 power negative 3. Okay, so here we have to move this point to here and to here. When we move it to here to be a 40, so this power will be a negative 5. Okay, so we have 10 power negative 3, 10 power negative 2 equals to 10 power negative 5. Okay. We will make it so easy. We will try to write it without a points, okay? Or we can, make all of them as balanced, okay? So here we have 80. We change it to be a 40. I think it will be better to write it like 4.0, okay? Or 0.40. So here we have initial length equals 2 meter, and we have if. You can write it if or T are the same, okay? It is a force, 80 Newton. Delta L, which L minus L naught equals 6.4, as also as millimeters, so change it to meter, will multiply by 10 power negative 3. Okay, students, so we have a given here. We have a diameter, initial length, and force, and also we have delta L. Okay, so student, physics is not like math. Okay, so you have to try to be a um, focus on it, the meters, millimeters, kilograms, gram, newton, pascal. This all about units. Okay, so try to make sure that you are using the right units. Okay, so we have here diameter 40 times 10 power negative 5. As we don't need a diameter, okay, we have to find radius. We have to find radius, which radius equals to d over 2, diameter over 2, diameter divided by 2. Radius is greater than diameter, okay? So d over 2. Here, d is 40 times 10 power negative 5 divided by 2 equals 20 times 10 power negative 5. Here is our radius, okay? So how you will find A? So student, here is, you will put all values in their positions, okay? So here we have area here, which is pi r square, pi r square. This is equals A, okay? So here's the value of pi is 3.14 and r square, we found it, 20 times 10 power negative 5 meters, okay? So you will multiply this number by using your calculator. So this m goes with this m, we left here n over m, okay? N over m, which is Pascal. If you have any question, you can ask me when we have a live class. Good luck, student.